So a little bit of background about myself. First of all, thank you for the opportunity to be able to present and to offer and chat about Intamsys solutions and products. Some very good information I've been able to gather so far about what's going on in the industry. Some very exciting things for additive manufacturing in general. So my background, I am currently the Director of Application Engineering here at Intamsys. And so I've spent most of my time, roughly 13 years, on the FDM technology side of things and focused on thermoplastics. And so what I wanted to talk to you today about was solutions for achieving aerospace applications with Intamsys products. And so we'll go ahead and just give you a little bit of a background about Intamsys. So Intamsys, we're creating infinite possibilities to customize your future. So Intamsys was established in 2013, and we have a headquarters in Shanghai, China. We've also got an office in Germany as well as the U.S. And so really we are focused on high performance 3D printing polymers. So we are well known for being #1 globally for 3D printing in PEEK material. Our product portfolio, again, we're focused on high temperature performance thermoplastics. So anywhere ranging from the 8K US price range up to 140K US. And so altogether, we have a core team of members on board that are very knowledgeable in this space and this technology to be able to work with our clients and customers in providing the best solution possible when it comes to FDM technology. Anyway, our solutions, we're targeted for the aerospace, automotive, electrical, medical, R&D, and other high technical industries. And so going through kind of for the time that we have, just kind of going through what our capabilities are, hopefully you guys will see and understand a little bit more of what the possibilities are. So our actual portfolio here that you'll see, so we range anywhere from a small single extruder platform, but small but very capable. This is the FunMat HT is our open source material platform. So being able to print with your PLAs, your ABS, all the way up into your Ultim materials, your PEEK and your PEKs, your PEKs. And so moving along with that from the FunMat HT, we got a Pro 410. So we'll move into our dual extruder system. Both our Pro 410 and our Pro 610 are both dual extruders. So that allows you to do multiple materials in the same print. You can have one model material and one support material to be able to achieve complex shapes and geometries. And so from the Pro 410 to the 610, something that we've recently released, we jump up into build envelope size. So now we're reaching build envelope size of 20-inch by 20-inch by 24-inch. And so this also as well, both the 410 and the 610 have the capabilities of being able to do, again, open source platform. We have a filament drying system on board, as well as other types of capabilities and components that make up the system in order to achieve and print with high performance materials. We also have it's a Flex 510 system. So this is somewhat of a newer system. And so this here has and gives the capabilities of being able to print with your TPEs and your TPUs. So your elastomeric and your flexible rubber materials. So for us, we have an end-to-end ecosystem for part production. So on the left side, we see processing software. So we do have, it's a license-free software that you can use. It's very intuitive. It also has different features inside. So if you want to select your different modes, if you're a new beginner or a basic user, or an advanced user, you can switch that setting within the software. And so going from beginner to advanced, for example, will open up a wide range of material tuning capabilities. And so adjusting your nozzle temperature, your build chamber temperature, as well as your cooling temperatures as well. So again, having that ability to be able to process your files for the wide range of materials that are capable with our systems. We have a very user-friendly interface as well, as you'll see at the bottom. So a touchscreen interface with all of our systems. Very easy, very intuitive to use. When it comes to materials, we work, as you'll see here, we've got material companies listed. Some of these material companies are very familiar in the industry, have been around for a long time, and very well capable in their field. So with the open source platform, we have the ability to work with these material companies. And so if you're a user of a system or interested in these systems, just to show you kind of the broad spectrum of those capabilities. Some of these companies too have been helpful to pioneering many of the aerospace applications that we see today. And again, just our printer platform that I just recently talked to in the recent slide, just to kind of to show the overall ecosystem of what we offer. So why know about high performance polymers for aerospace? So number one, our printers have the capabilities to accurately print high performance polymers that have paved the way and have achieved some very successful aerospace applications. And with doing that with an affordable entry point. Number two, we have an open source platform that allows the advancement of future materials, including hybrids. And with this, it's going to help to lessen the constraints of the application possibilities, application development, research and development here now and into the future. Number three, our material offering that has the characteristics and makeup, the materials that we offer that I'll talk a little bit about, past certification standards to be able to use, for example, within interior aircrafts and additional end-use components for aerospace. Down at the bottom, something that Dave had mentioned in his previous presentation is that the aerospace industry is progressing towards end-use production parts, specifically in FDM. So with that comes the demand for higher demanded materials. So doing 3D printing in aerospace is nothing new. This has been something that has been going on with the material capabilities that are available there today. High performance polymers, for example, this allows to be able to achieve various applications, high demanding applications, parts that are going to see real world environments. So proven materials with infinite possibilities. So here are three material categories that are targeted within the aerospace industry and used. So we have our PEIs, so our Ultim 985s, as well as our Ultim 985 carbon filled, Ultim 1010. We have our polyether ketones, so our PEEK or PEEK CF, PEEK GF. Again, some more high performance filled materials, and then we also have our nylons as well. So the key benefits with using these materials, high strength requirements, being able to achieve that. Flexibility gives you the rigidity, UV stable, toughness, static dissipative, elastomeric, and these materials here are resistive to high heat applications, as well as various chemical resistant applications, and it comes with the corrosiveness as well, the corrosive resistance, and flame retardant as well. So just an example here of jigs and fixture applications in the aerospace industry. Lightweight it helps to increase the fuel efficiency, and really nowadays additive manufacturing is doing many things to be able to help eliminate the CO2 emissions. And so in aerospace, we know that weight is key, right? And so any opportunity that you have to be able to reduce the weight in your components across the board is a huge factor, and it's very impactful. So here we've got some fixture monitors that we printed out of our Ultim materials. As you can see here, 40 to 50% weight reduction. With the freedom of design that additive manufacturing gives you, you're able to get more ergonomically friendlier parts. You're able to go in and do a redesign the way that you want to, so you're not constrained by design. FDM and 3D printing allows for breaking down those design barriers. And so with these types of parts and components, a very quick turnaround time, and you're getting something that's accurate and something that you can actually use. So electronic connectors and retainer components. So high performance solutions offer greater versatility, reliability, design freedom for electrical devices, And so as you see here, this is some electrical connector components that we have. There's both a combination here of TPU material, the black component that you see in the upper right, that was printed out of TPU, and then the components below are printed in our PEEK material. We've also seen other components printed with, like I mentioned earlier, static dissipative properties. So again, this helps to decrease the time in production, to save on conventional tooling. If there's only 250, maybe 350 components that are needed, for example, 3D printing is a good fit for that. And so that helps for faster processes and decreasing the time to market. So end use application stories. So Commercial Aircraft Corporation out of China. So we have them as well, and have worked with them on PEEK CF. It's a lampshade overhead housing. So again, just the fact of being able to decrease their time to market, have a part that has high wear resistant capabilities, and also have something that's digital inventory, something you can do on demand. So just an example of areas in the aircraft of where the components can be used. So you see here in the picture, I've highlighted some areas. We see an armrest, we see chair fixturing, we see paneling, we see vent work. There's wiring harnesses and venting and ducting that can be used for interior aerospace components when it comes to FDM technology. So achieving low volume and large part production. So here's some examples of some parts off of our Pro 610. So you can kind of see the variety of different parts here in sizes. Down the lower left-hand corner, you'll see a bigger housing that was printed in our Ultim 9085 material. It's a dash paneling with the touchscreen inserts that can be printed off of this printer as well. So you also see the opportunity to be able to do low volume production off this printer and off of our printers in general. So yeah, just overall a good example of the capability. So endless applications, and that's today. So composite layup tooling, jigs and fixtures. There's soluble tooling, wind tunnel testing, lightweight structures, honeycomb interior type structures for lightweight, keeping the structural integrity, and then also topology optimized components. So being able to adjust your file for additive manufacturing to reduce the weight, but also keep the structural integrity.